So again, the form for logarithms is you have your log, the base is your subscript, the answer is going to equal the exponent. A log always equals an exponent. So for number 26, this is an exponential function. How can we rewrite this in logarithmic form? How can we take this exponential function and rewrite it so that it looks like this? Log base answer equals exponent. Brianna. Oh, you can't talk. Oh, all right. So you change your mind? You don't want to answer it anymore? Michael. Equals. Exactly. That's all you have to do. Log base 9, 729 equals 3. That's all you have to do to rewrite exponential form to logarithmic form. Haley.
The 729, is it raised or is it just?
Yeah, it's just on the same line as the log. So the way we read it, you have to read it the right way. It's log base 9 of 729. So you might want to write that down. The way you read it is log base 9 of 729. Log base 9 of 729 equals 3. So again, we have another exponential function. 6 squared equals 36. 6 is the base. This is our base. This is our exponent. 6 is the base. 2 is the exponent. And 36 is the answer when we raise 6 to the second power. Base, exponent, answer. So in logarithmic form, Anthony. Thank you. Log base 6 of 36 equals 2. And again, the reason why we use logs is over here, this is not an equation we have to solve. We already know that 6 squared equals 36. But if it were an equation and it read 6 to the x equals 36, if we didn't know that this was 2, we would just rewrite it in logarithmic form and throw this in a calculator to get the exponent, to figure out what the exponent is. But we just have to practice putting it in logarithmic form first. All right, how about this one?
Log is 100
Yeah, log base 100.
equals 10. No, no, of 10.
Oh, no, no, not log base 100. Sorry, it's not log base 100.
It's backwards.
Yeah,
So it's the same thing. So it's log base 10
log base 10
of 100 equals 2.
of 100 equals
Sorry, I
2.
was reading it.
It's not a problem. So what this means is 10 raised to the second power equals 100. Now, here's another thing. You might want to write this down. You know when you have x to the first, you don't have to write the 1, correct? You could just write x. Say you have 1x. You don't have to write the 1 in front. You could just write x. Does that make sense? When you have the base of 10, when you have the base of 10, you don't have to write the 10. Yeah, so the universal log is always 10. So you don't have to write the 10, you could just write log 100 equals 2. So if you don't see the base, that means the base is 10. The same way, if you don't see the exponent, you know the exponent is 1. If you don't see the coefficient of 1, you know that the coefficient is 1. Like if you don't see a 1 in front, you know the 1 is there. If you don't see the 10 if you don't see a base here, you know the base is 10. So it's log 100 equals 2. You don't have to write the 10. If the base is 10, you don't have to write it. Just like if the exponent is 1, you don't have to write it. If the coefficient is 1, you don't have to write it. So just log 100 equals 2. Haley.
Log base 1/2 116 equals 4.
Yeah. Log base 1/2 of 116 equals 4. All right. Go ahead, Jordan.
Log base 49 of 7 equals 1/2.
Log base 49 of 7 equals 1/2. So I hope at this point everyone understands how to take an exponential function, rewrite it in logarithmic form. Now let's go in reverse. Now we're going to have the logarithmic function first. We're going to have to write it as an exponential function. So the other way around. Number 28, you have the logarithmic form. What do you think exponential form would be? Just think about it. What's the base here? What's the exponent? So it's 4 to the 4th power. What's the answer? 256. So 4 to the 4th power equals 256.
So what if the birth doesn't equal anything?
Then it would just be an x. Oh, you mean 0 or like nothing there?
There's nothing there.
Then it's just asking you what's the value. It's always going to ask you what's the exponent. So it's just equals x and you solve for x.
Oh.
Yeah. So 28 is 4 to the 4th power equals 256. How about 29? Maria G.
Is it 7 to the first equals 0?
It is not. What's the base?
7?
What's the exponent?
Oh, 0. So then equals 1.
Yes. So 7 to the 0 power equals 1. As you all know, anything raised to the 0 power is 1. 30. Allison. Exactly. So hopefully you're all seeing that a log is an exponent. So whatever this log is the exponent. 5 is the exponent. Do we need to continue? Julie, you want to do the next one?
Yeah. 10 to the power of 1 equals 10.
How do you know that 10 is the base?
It's not there.
Exactly. There's no base here, so we know that the base is 10. So 10 to the power of 1 equals 10. Nice job, Juliet. So we know that the base is 10 because it's not there. In. 5 to the first equals 5. And go ahead, we might as well finish it off. Angelina. 8 to the negative second power equals 1 over 64. So those are logarithmic functions. A log is an exponent. A log is an exponent. Whenever you find a log, you are finding the exponent that you raise the base to get the answer.